everybody. So I live in Boulder, Colorado, and who's been to Boulder? All right, it's good. It's like the mini Portland almost, so works out pretty well. Good friend of mine is Ara Howard. Who recognizes that name? Okay, just Google a.rb if you don't, and you'll find him on the internet. His company is called Dojo 4, and I'm sitting in the front of Dojo 4 one day, as I do most days these days, and he's like, "Hey, Jeremy, what do you know about transcoding movies?" I go, "What do you want me to know about transcoding movies?" I work for myself, hey. And he's like, "Well, we have a customer, MovieMe, who needs to transcode movies to put them on iPads so that people can watch them on planes." I'm like, okay, that's kind of cool. So, hey, transcoding movies. Wonderful. Let's get started. So what do we have to do first to transcode movies? We got to have movies. Or films or cartoons or whatever we are. So there's some infrastructure already set up around. We know it's going to be done in EC2. We have movies that are going to be in S3. Currently, the movies are at studios. So what do we got to do first? We got to get the movies from the studios to the transcoders, which is great. How are they going to get there? We're going to ship it. Studio's going to ship us some movies. Thought about trying to upload it, but this is just one batch, one box, 4 terabyte hard drives. They're going to ship it to us, FedEx, $100. Run some back of the envelope calculations and go 16 terabytes of movies, 50 megabits a month. Okay, that's not really tenable, so we need to get them there faster. Who has faster than 50 megabit speed at their office and GitHub doesn't count? Okay, yeah, but you guys both, oh, no, okay. So this was like a friend of mine who has a small ISP, and he said I could give it a shot, and we're like, okay, let's run some calculations. Yep, that's not going to work. So, does anybody else know what we did? Ship it, yes. We shipped it in a different way. How many people have used Amazon Import? How many people know of Amazon Import? All right. So Amazon Import is this great service where you ship them your hard drive, and they load it into S3 for you. So instead of waiting 30 some odd days, we're going to pay an extra $450 and we'll have it in 4 days. Sounds great. Awesome. So yeah, this is one of the best things that I learned how to do in the past year was log on. And the fun part of this is there is no GUI for this. You have to download Amazon's jar file so that it can issue one specific command. This is how you do it. You create a manifest file. You prepare your device for shipping, which means you have all of the cables and all of the power and the box that it goes in, and the box that the box goes in, and all the shipping labels correct, and everything is labeled. Then you file a create job request. This is actually the Java thing. We'll go out, take your manifest file, and response, get a signature file. You put that signature file on the root of your hard drive, and you ship it, literally. Here's your manifest. It basically says, hey, where's all the data on this stuff go? I'm going to, that's your access key. What bucket does it go into? What's the device ID on this thing? What's the prefix in the bucket that all of the files are going to go into? So this was shipping hard drives from Disney. I randomly generated device numbers. It was the easy way to keep them apart. And then at the bottom, the return address. So there's a couple interesting things you can do with Amazon. You can have them shipped back to you, or you can have them shipped back to somebody else. So say you are working with a data provider, and the hard drives are actually theirs. So you could say, oh, I want you to ship the drive back to my data provider so that I don't actually have to deal with it anymore. The other thing is they'll erase the device for you. They'll do a level 0, just zeros all the way across the entire hard drive for you before they ship it back. Really cool. This is the file that gets put on the root of your hard drive. It's just a tag that says, here's everything, so that Amazon, when they get to hard drive, they can plug it in, basically look at the root of the file system, look at this file and say, okay, which job does this go with? That's awesome. And this is what it looks like in shipment. There's some interesting stuff. One, the documentation on their website says, you shall ship 1 drive per shipment. Well, you can call them up and say, I got 40 drives I need to send. And they go, over how much time? Because I think we shipped them all to Seattle, and I don't know how many bays they actually have. Anybody here from Amazon? No. And the guy I was chatting with on email said, Yeah, you may not get them all at the same time. Well, we have to fill all of the space in with everybody else who's shipping us drives. And you've got 4 terabyte drives. A lot of people are shipping, gigabyte hard drives or USB drives or downloading data from S3 buckets. But some of the interesting thing is these stickers provide some extra stuff. We had FedEx lose a box. So nothing like losing a box of hard drives from a studio with extremely high resolution unencrypted movies on it from the studio. That was an interesting thing I learned. The studios, they ship unencrypted like master copies. These are 200 gigabyte files. So that 4 terabyte drive has 16 movies on it. That's it. And we're talking full length, super HD, like maybe better than theater quality film. FedEx, one of their conveyor belts, ripped the top of the box off, and so they lost the shipping label. Now the fun part is apparently FedEx is pretty good about putting the other markings on a box into their database. So I call them up and like, hey, that box that was supposed to be shipped and show up yesterday, I haven't heard from it yet, and where is it? It still says it's in Nashville. And the person says, oh, let me look in. You got any identifying characteristics on the box? I'm like, well, there's these 6 labels on it, and here's what they say. And the FedEx person said, she actually just typed it into the computer. She's like, oh yeah, we found it. It's on shelf 35 in room blah, 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 because they put all the identifying characteristics of the box in the computer so they can find out which one it is. It was great. I was like, so, lesson learned. Put extra stuff on the box that identifies it as yours in case it gets broken in shipment. And there's a very important lesson that was learned in this little piece of the program here. How many people know this quote? How many people own this book? All right. How many people use this book in college? All right. 3 of us. Excellent. Or the more modern day equivalent is XKCD What If number 31. Because we were actually shipping hard drives via FedEx, this was actually pretty good. So it's going to be a while before shipping 16 terabytes of data via hard drive is slower than doing it over the network. So now we have, well, in this case, that was just 4 hard drives. We did 40 to begin with, and we've done a few more. So in roughly, I think there's about 2,000 movies up there right now. The next thing we have to do is we need to transport it within Amazon's system. How many people have done large file transfers between S3 and EC2? Yeah, what's the best bandwidth you ever got out of it? Exactly. So we got this right here. S3, we need to pull down to EC2, 200 gigabyte file. Best I got, average about 7.5 megabytes a second, which means downloading that movie from S3 to an EC2 instance, which costs $1 some an hour to do, is 7.5 hours. So, HTTP standard, RFC range, or the range header, which you can do simultaneously, or parallel. So the fun part is apparently it looks like Amazon is throttling per TCP connection. So if you've got a bunch of TCP connections, you can download the file way faster in parallel, which works out really well. So I had an 8 CPU machine, 200 gigabyte file, 7.5 megabytes per second per connection, 8 connections, an hour. Yes, much faster. Now some of you might have heard of this. Has anyone heard of this? Oh, so S3, if you put .torrent on the end of your GET request, you can get the torrent file for your item that's in your bucket. Sounds like a great idea. Not really. Not really sure why that's there, but apparently that's the rule. So now we have files down on our EC2 machines. We're ready to transcode them. And we're going to skip the transcoding, that's the next act. But how about we want to put those files when we're done back? So we've got these 200 gigabyte files. MovieMe would like to have 2 transcodings, one to a Blu-ray similar quality, and one for the like 1 gigabyte, 1 megabit per second movie, about a gigabyte download for your iPad. So we got 2 artifacts we need to ship back up. One of them's probably going to be about 20 gigs. The other one's going to be about 1 gig. So we'll just ignore the 1 gig. That's sort of, whatever. But we still have a 20 gig file that we haven't stored yet. Our connection at 7.5 megabytes per second is almost an hour for this 20 gigabyte file. How many people have used Multipart Upload for large file movement. Anything that's over 5 gigs in Amazon, you have to use this, guaranteed. The interesting part is you can use it for things that are greater than 5 megabytes and greater than 5 megabytes period, because every file can be up to 10,000 parts. Each one has to be at least 5 megabytes in size, except for the last one, and it's fully parallelizable. So if you've got a 5 gigabyte file, 1 gigabyte file, break it up into 50 pieces, upload them all at 7.5 megabytes per second, and hey, it goes a lot faster. Now the interesting thing is your E tag will not be what you expect. Most E tags for S3 buckets are the MD5 sum. The E tag for multi-part uploads are way different. So we have 20 gigabyte. 8 connections, 5 minutes. Sweet. An hour to download, 5 minutes to upload. One interesting thing, how many people have used the AWS SDK library in Ruby? Do you like it? No, it's sufficient, but for stuff like this, it just doesn't work. So whenever I'm trying to find a problem or trying to solve a problem, first thing I do is see if I don't have to write any code. So this is actually a really nice little Python library that has a command line to it. And from my perspective, the two best types of code are the one you can delete and the stuff you never have to write to begin with. So this is a nice little, uses Boto, which is the Python Amazon library. And I think if I'm correct, the Boto committer actually works for Amazon now. So this is a pretty good little library. So now we can download the movies pretty quick to our EC2 instance. We can upload them pretty quick when we're done. Now we just need to convert them. All right, that should be easy, right? So now it's time to transcode these movies from our original source to our final destination. So, hey, as someone in the open source world, here's your Swiss Army knife for doing movie transcoding, conversion, anything like that. Now, I know there's a couple of people in the row here, and they're welcome to heckle me when I get stuff wrong, because they have work or currently do work for a company that does this professionally. So the thing we have to worry about first, what are we getting from our studio? Well, we have Fox, Disney, NBC Universal, Warner Brothers, independent film companies, and more coming down the road. Nobody's consistent, not even within one company. We have one of the studios said we will make sure that all of our videos are exactly the same when they ship them to you. Yeah. So, and our output, since this is an offline viewing on a portable device, the licensing restrictions for this type of item require from the studios that it be encrypted and licensed. Now, we can all have our opinions on that, but this is a contract and we'll have to deal with it. And there's a system called, is it Play Ready? Play Now? Play Ready. Play Ready. Okay. Which is basically what the entire entertainment industry is using for licensing of their content in a digital format. And it requires something called the Protected Interoperable File Format, or PIFF, which that's the standard. Its name is IIS Smooth Streaming Video. Do you know who created the standard now? Yeah, it'd be Microsoft. And the file ending is ISMV. So those don't really jive, but we'll have to deal with it as we go. Going to sidestep right now to tracks and channels. Now, I may get the terminology wrong from, this is the way I think of it. So we're going to talk about movies, and a movie file can have many tracks. Each one of those tracks can have a different type of data in it. You can be a video track, an audio track. It can be closed captioned, and I've seen some just data tracks that I have no idea what they are. The other thing is channels. So any track can have multiple channels. Most people think of this in terms of audio. If you've got a 5.1 audio track, it's going to have 6 channels, your surround sound, and low frequency for the .1. Now the fun part is, by far, most of what we've gotten from our customers is one video track, 1 to 16 audio tracks. When it's 16 audio tracks, most of the time it's 16 mono tracks, where each track can be a different channel. So center, front, left, right, low frequency, blah, 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 8 channels. And then the same 8 channels again, but with no actor voices. It's just, what do they call it? effects and sound, and then one or more other tracks. Although one time we did get one that sent us a 2-track file, but the one audio track had 16 channels in it, which is what it should have been when it was, should have been 16 tracks of 1 channel each, and they sent us one that had 1 track of 16 channels. That was fun. And what we want to give our customers, or what we want to put out is 1 video track, 1 audio track with 2-channel stereo. Nice and simple. Have I lost anyone yet? All right. Has anyone heard of this? ISO-based media file format. So it's exactly what it is. International Standards Organization based media file format. It's kind of weird. I have to digress on this for a moment because this is the lead into the entire story of this piece of the act. ISO file format, it thinks of itself as an object. You have this huge big expanse of data, and at the beginning it says what kind of object the entire container is. And inside that container is other containers. And inside that container is more containers. And they all have 4-character codes at the beginning. Move, track, 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 mdata, moof. It's a 96-page standard. And this is it. Feel free to download it and read it. You'll enjoy it. It's riveting, let me tell you. But it's basically boxes all the way down. Think of it like a matryoshka. Actually, matryoshka container probably has that name for a reason. And so it's boxes all the way down. You've got moof, headers, tracks, TFDHs, blah, 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 all sorts of stuff. In any case, the input we get from our studios is ProRes, which is Apple ProRes, comes out of Final Cut Pro and various other different things. And it is an extension of the ISO-based media file format. The output is PIFF, which is also an extension of the ISO-based media file format, specifically for encryption, DRM, and multi-bit rate tracks. Not going to worry about that right now, but what we have is a few standards. So you think, hey, I'm going to use ffmpeg. I'm going to convert one standard to another standard and just change the resolution. No, this isn't working. I'm sitting here, and the fun part, how many people have tried to debug movie rendering problems besides you two? A couple in the back. So it's really hard to try to debug a feature-length movie when you're rendering because you might have a 4-hour cycle time for each test. So what we're basically trying to have is trailers. I have heard somebody tweeted on the campfire, I've seen the Carrie trailer 86 times. I've seen the Battleship trailer untold number of times with various different sound channels turned off. Let me tell you, that is an interesting thing. Watch any action-adventure movie without the sound effects. No, seriously, you should try it sometime. There's about 12 lines of dialogue in the whole movie. It's great. So the interesting thing is, at this point, we're going, okay, I've got my input ProRes. Let's just try to make some standard MP4 files. It's working great. It's great. I can watch it. It plays in player on the iPad. It works great. Okay, let's try it in the ISMV format. Okay, yeah, that's not working. Dang it. They're both roughly the equivalent, the same file format. Why aren't they not working? So a couple of days of just trying different ways, mostly Aj's approach. Take one thing, change it, change one, try it. Why doesn't it work? Keep on cycling and cycling and cycling. And we finally realize, okay, maybe it's not our fault. So that's the first thing anyone has to do when you're debugging a problem is assume it's your fault to begin with. At this point, we've pretty much eliminated all of our code, and we're trying to figure out why this isn't working. So it's time to compare. Pull up the ISO-based media file format in one screen, the PIFF file format specification in the other screen, and start writing some really bad Ruby code to just dissect the file and make sure that all the bits are in the right spot. So there's some really good Ruby code, really good Ruby libraries. There's 2 right off the top of my head. I can't remember right now, but find me afterwards and I'll get them for you. That are really good for unpacking binary files in Ruby. And all I'm basically doing is stripping through the file, looking and making sure that the data looks according to the standard. So I'll take a known good ISMV file and compare it to, I'm going to do a conversion, and this other licensed software that they didn't want to use and we still had a license for it, and do the conversion twice. Same input, 2 different outputs, compare them compare them side by side. It's working great. All the bits are looking exactly the same until I get to this thing called a track fragment header box. Don't worry about what it means. What we do want to look is at the ISO-based media specification. It says the following flags. This flag, 1 bit, base data offset present, indicates the presence of the base data offset field, which is the next 4 bytes, optionally. PIFF specification. The base data offset field must be omitted. So that means, in layman's terms, ISO spec, here's a flag. It can be on or off. PIFF must be off. So what is ffmpeg doing? Setting it on. So I'm at pull request, ffmpeg. I have it in there. This is the fix right there. Move TFHD base data offset binary 1 bit or in this flags for ISM files. 1 line of code change, 2 lines of comments. It's in there now and it works. So figuring this out took about a week. So how many people have done a week's worth of work to make 1 bit of difference? All right, we've got a couple over here. Okay. It's a bad joke. I had to do it. The last piece. So we've got data coming down. We can transcode to the appropriate format, and we want to shove the data, and we can shove the data back up. Now we need to tie all the room together. So we have our content, transport it, transcode, but we have a couple thousand movies we need to do. So in any approach to some problem like this, I want to do the simplest thing that could possibly work. And if we think of this in terms of if you just had your laptop, we've got all this data in S3, which is basically a directory of input files. We want a series of output files. And the basic structure of all of this is pick a file, download it, transcode it twice and a bit more. If you want to know more about why that is, come talk to me later. Upload the results. But if we put some time things on here, pick a file, download it, about an hour, transcode it, about 8 hours of work. This is CPU, full on, machines just blasted on the CPU, 8 hours of work. Upload the results and be done with it. So, got 1,000 films, actually more than that, but this is just back of the envelopes. And the initial limit on EC2 instances, I think, is 12, 25, I forget what it is. But I was like, okay, well, this is why we have EC2. I can just say, I want 1,000 instances, do it all at once. So I wrote to AWS support to ask have our limit raised. That's basically what I got. We did negotiate. They did raise our limit to about 250 simultaneous M2 extra large instances, which was very, very nice of them. Most I ever had running at one time was over 200, which was kind of fun. And then the next thing we want to do is, okay, so I want each one of these machines to do 1 transcoding job. So I want to turn an EC2 instance into basically a shell script. So when it comes on boot, what are my options? Well, you can use first boot, but that only works on Debian, which we actually weren't using. Init scripts, well, it only needs to run once. Why would I need a init script for reboots? Because if it reboots, I've lost all the data. We're using local ephemeral disk for the intermediary file thing. So if it reboots, we've lost all the data anyway. Well, how many people know about rc.local? All right, rc.local. It works pretty much on every single Unix under the sun. It runs on boot, and that's it. Almost the last thing before init runs. So we're going to take this transcoding in 1 command and run it from rc.local. Here you go. The other thing is /mnt is where Amazon by default puts your ephemeral disk locally. And basically, movie.farm bin encode is our script. Now the interesting part is we don't know which movie we're doing here. So what we need to do is feed this thing some parameters to tell it which movie in S3 to download and where to put the results. Does anyone use user data in Amazon? Wow, all right. So there's this great thing. How many of you have an EC2 instance right now? Curl that URL. Actually, curl anything at that IP address. There's an amazing amount of data you can learn about your instance just by curling the entire directory structure. There's metadata, there's user data, there's a whole bunch of information about your particular instance that is at that URL. And a whole bunch of other things. There's an entire suite of documentation on all the data that's available right here, and you should look at it. Now the interesting part is, at this URL, you can store 16 kilobytes of data. Whatever you want. It doesn't matter. I think, a couple of different cloud stacks are using this to determine all the packages that need to get installed on a machine or init scripts that need to get run. I'm just going to throw some YAML in it. This is the file the bucket that our incoming file is, the movie to download, where to stick the results, and then some tuning parameters for the movie. This is pretty good. It works out pretty well. So that encoding script, when it runs, when it kicks off, just curls that URL, takes the YAML, and runs the job. Works all well. Now the next thing we want is, I don't want these instances running around. I don't want to see a whole bunch of red dots in my AWS console all the time. So I want this machine to just disappear when it's done. Now, I thought, well, okay, what am I going to have to do? Am I going to have to look at all the instances, look at the controllers, see if the machine's actually done, and then delete it? Well, there's this other thing. How many people have used this? No one has used this? This is amazing. So the default way when you do shutdown -h now on an EC2 instance, it just powers down like you would normally. Well, there's this other behavior. When you create an instance, you can change its shutdown behavior. And this one is terminate, which basically means implode, destroy yourself, release it back to the wild and into the pools. So this is the AWS SDK. So we've got an image, which I haven't talked about. It built up an EC2 image that had all the software on it we needed. The instance type, M2 extra large, shutdown behavior, and the user data is that YAML string. Send this off, machine boots up, RC local runs, downloads the data out of user data. The entire thing runs for some odd 8 hours until it's done, and when it's done, shut down -h now. Boom. That's a whole other talk on the job synchronization, all that kind of good stuff. So, a lot of interesting things that we've learned in this process. So our final thoughts. No, it's got really crappy ping times, but it's got the best bandwidth. Read the documentation. Hey, I wouldn't have known about AWS if I hadn't been trolling around in the documentation to figure things out. Look for tools that already exist. If you've got something, don't always try to write your one the first time. Look for something that already exists. It doesn't matter if it's a different language. If it's got a command line, it works. Read the documentation of those tools that you're just looking at. Maybe they have some features that you haven't looked at yet. Chain simple things together. So what we have here is a URL, a Ruby program, a shell script, rc.local, a couple other shell scripts, ffmpeg. All of it is basically, Ruby in this entire system is basically command and control. It's just monitoring files in different locations, kicking off scripts to download things, kicking off ffmpeg, launching new instances, and then there's some other things in the background for monitoring job completion and things like that. But, again, read the documentation. And I think one of the things that's most important on all this is, I pulled this from Glenn Vandenberg. He has a great talk on visiting all the turtles. And I think this is very true. In this case, I learned a lot just by looking at the MP4 file format and the ISO-based media file format and understanding how these media files work. And with that understanding, is some really good stuff. So again, read the documentation. And thanks. Dojo4 and MovieMe was very kind to say, hey, go ahead and talk about what you did. It's pretty interesting stuff. So, hey, thanks to everybody. If you have any questions or stuff, we'll just chat in the next break. So, thank you all.